John Mealy with Hobas Pipe, National Business Development Manager. I would like to thank everyone who's attending today. Our pre-recorded technical presentation on Hobas fittings and vertical shafts is something I think you will all find of interest. Our presentation will run approximately 15 minutes, and our panelists will address questions at the end of our presentation. Gina? Back in 2019, Hobas introduced our FRP NC product to address our nation's aging non-circular pipelines. This product was designed as a fully structural pipe to address the rehabilitation of existing non-circular shapes and to address direct bury applications. If I may, I'm going to now introduce our panelists. Gabriel Casablanca, he's PE with Hobas Pipe, Development Manager for our non-circular pipes for North America. Ms. Kimberly Bajoli, Vice President, PE, or QA/QC at Hobas. Last, Mr. Terry Anderson, Product Manager for our vertical structures with Hobas Pipe USA. With that, I'm going to start off with Gabriel, who'll give a short overview on Hobas Pipe.
Before we introduce our new products and market segments, I'd like to offer a brief introduction to our company and overall goal. Hobas Pipe USA is a producer and international supplier of corrosion-resistant centrifugal cast, fiberglass reinforced polymer mortar pipe systems. As part of a global technology, Hobas history in the U.S. began in Houston in 1984, and the plant was built in 1987. Since then, close to 10 million feet of pipe have been installed in the USA. Our pipe product is known throughout the world as a leader in corrosion-resistant, fully structural products able to withstand the test of time. It is clear any new product we introduce to the market has to be able to share those benefits our clients expect from our brand. Hobas has been producing fittings for just as long as we have been producing pipe. We have over 3,300 fittings manufactured in the last 5 years. All the fittings we produce are made to order for each specific project. Our customers know they don't just have to have a 30, 60, or 90 degree elbow. They can have a 34, 47, 72, or any angle dictated by the alignment they encounter. It's this high level of customization that has led to some of the most complex fittings we do today, like this 96-inch bifurcation wide. At the time, the largest fitting we have ever manufactured. Since then, they are becoming even more common and complex. We can even include reducers and necks and make them as part of a manhole system. One of the most recent interesting fittings we have designed was this fitting in collaboration with a Texas agency. The general design was used to replace junction structures in various parts of their projects. The main issue they were having was the large amount of time to produce a concrete structure with a much shorter lifespan than the pipe adjacent to it. Hobas was able to come up with a solution that not only saved construction time, but also significantly reduced initial and lifetime cost. All that experience with complex projects and complex fittings has led us to venture into tackling all aspects of a traditional sewer system. This led us to manholes. Traditional issues with manholes were either too heavy, short expected life, too weak, or just not cost effective. Hobas Pipe Manholes addresses all these issues with an exceptional product that is very strong with a wall 15 times stiffer than similar FRP riser products, 6 times lighter than concrete manholes, and an expected service life of over 100 plus years. Our first objective was really to understand the current need and issues with the current manhole system. A manhole's goal is to create a permanent, convenient, and safe access to a sewer for sewer maintenance, repairs, and inspections. Additionally, because of the gases produced by the sewer, ventilation was also very important. All the while supporting external loads from traffic, soil, and hydrostatic loads. Because of the corrosive environment of the sewer, most failures of manholes start as corrosion failures. Lastly, it is critical that the manhole has a tight seal to the sewer pipe, as this place is where the infiltration is most likely to occur. Our manhole solution addresses all these requirements and issues. Manholes have evolved from a wide variety of materials and shapes. We even had rectangular manholes which seemed simple to excavate and simple to construct. The more common materials were either stone, wood, or brick. Eventually, manholes changed to round as they were able to sustain the uniform loads a lot better by putting the manhole in uniform compression. This meant that the manhole was able to sustain higher loads using even thinner walls. As you would expect, brick was the preferred choice. Additionally, brick was naturally corrosion resistant. The challenge then became the mortar decay due to the corrosion and the large infiltration due to the hundreds of joints. Concrete manholes addressed many of the issues posed by brick manholes. The number of joints and leaking points was substantially reduced. The concrete could be designed to resist all loads. However, it opened the door to other challenges. The heavy manhole sections were extremely heavy to be handled by regular equipment, requiring heavier cranes. Additionally, the corrosion issue still persisted, and the infiltration, albeit reduced, was still substantial. Rightfully so, manholes then evolved to use lightweight FRP manholes. This was a great solution because it offered incredible longevity, corrosion resistance, lightweight, and all at a low cost. However, the thicknesses used were extremely low, resulting in a pipe that was harder to handle and was more prone to buckling. A good alternative to lightweight FRP manholes has been heavyweight polymer concrete manholes. These manholes are stronger than the lightweight FRP while still being corrosion resistant, since they are made using resin in lieu of cement. This type of manholes, however, are very heavy and have a very high cost. So let's compare the best alternatives in the market to what Hobas currently offers. First, we can see that all materials are corrosion resistant and for the most part are able to withstand loads. However, there are two key items that differentiate Hobas from the rest: strength and weight. Polymer concrete has great strength, albeit at a very high weight. Lightweight FRP offers a low weight at the cost of a much lower strength and ease of installation. Hobas Pipe is able to balance these two key features. It is just as strong as polymer concrete, but has a heavier weight than lightweight FRP. This thicker wall results in a higher buckling capacity, while also having enough weight to overcome flotation forces. The first part of the Hobas manhole solution is the T-base. This is nothing new, as for decades this has provided a uniform, smooth transition at manhole locations. This is because both the base and the joint are made of the same Hobas pipe and the FWC coupling as the rest of the sewer line. This reduces turbulence and ensures a zero leakage connection. The design of the Hobas manhole system was a two-part process. First, we modeled the pipe in FEA to better understand the expected levels of stress and strains, as well as to understand which sections of the manhole would control the design. After this was done, we produced prototypes to test. The results from the test were very encouraging, as it proved several things. First, that the manhole met the required loading conditions per ASTM D3753. Second, that the manhole's cone was so strong that the concrete rings broke well before there was any damage to the cone itself. Third, the strengths measured were very consistent with what we found in the FEA, proving our model worked. The Hobas riser pipes will then connect to our new Hobas cones. The cones have been designed to not only meet the required ASTM standards, but exceed them by a minimum of 50%. I will now turn it over back to Kim to discuss testing.
Thank you, Gabe. The next few slides I am going to go over the testing that is required by ASTM D3753 for manholes and the results of the tests completed by Hobas. In summary, Hobas has completed or is currently performing the following tests. Material composition is verified on every manhole. Mechanical tests for flexure, compression, and tensile strength are performed on laminates of similar composition. Chemical tests per C581 and D3681 are ongoing and regularly verified. Load test per ASTM D3753 was performed at the University of Illinois, Urbana, and we're going to go through that testing. Soundness test per ASTM D3753 was performed after the load testing, and thickness and hardness verification is performed during the manufacture of each manhole. All of the mechanical testing which is required for manholes is testing which Hobas routinely performs in Houston for the centrifugally cast and non-circular pipes. The tests include ASTM D695 for compressive properties, ASTM D638 for tensile properties, and ASTM D790 for flexural properties. Chemical testing of Hobas pipes is performed in accordance with ASTM D3681, the test method, and D3262, the product standard, for fiberglass sewer pipe. Testing for 3681 has been ongoing since 1987 in Houston, and in fact, the bottom right photo is a picture from the Houston lab. It's a specimen which is still running today, and it was set in acid in 1995. Additionally, corrosion testing per C581 is performed on specimens taken from sheet laminates made of the same composition as the manhole cone. Several test media are chosen to ensure long-term performance in a wide variety of chemicals. The real proof of performance lies in the load testing. Two tests were performed on the completed system. The first, a 48-inch diameter riser section with a 24-inch concentric opening, and the second, a 72-inch diameter riser with a reducing section to 60-inch diameter and a 30-inch cone opening. The ASTM standards requires that the manhole be long enough to include at least one of all unique or repetitive features. In any case, the minimum length of the manhole cylinder shall not be less than 36 inches. In the case of both manholes tested by Hobas, the total length was 10 feet, well above the requirement. The test was performed as outlined in the standard, with the complete cover and grade ring installed and the specified load applied eccentrically on a 6-inch by 6-inch by half-inch steel plate resting on the manhole cover. Before the testing was performed, a series of sensors and gauges were installed. During the test, we were able to record the vertical displacement of the 6-inch plate relative to the floor, the total load on the manhole, as well as taking strain measurements at various load levels. Strain gauges were applied to various critical points on the manhole to verify the strain levels that the FEA had previously predicted. These gauges are not required for the standard, but provide a valuable resource for information to assist in future manhole designs. Here's another photo of the strain gauge application. Sensors were placed along the critical points in the configuration. The load test was a tremendous success. The standard has several requirements for performance. At 24,000 pounds of load, the vertical deflection shall be less than 0.25 inches. In our test, the deflection was about 2/3 of that, or 0.17 inches. The manhole was also required to pass a load test which consists of applying force in 2,000-pound increments up to 40,000 pounds of force. We hold this load for 15 minutes. During this test, there was no evidence of damage to the manhole. Next, the load was increased in an attempt to find the ultimate capacity of the manhole. Ultimately, the load was elevated to 60,000 pounds. In both cases, although the fiberglass manhole was undamaged, the ultimate capacity of the system could not be verified. In both tests, the seal cover, and in one case, the grade ring, was damaged and could no longer take further load. The final phase of the testing was to perform an internal pressure and vacuum test to ensure the tested manhole is sound. In both cases of loading the specimen, no damage was found in the structure, and therefore no leaking was found during either the vacuum or the internal pressure test. All of these test reports I've discussed today are available to you upon request. Once we finished all of our testing, we were on to the next phase of our manhole introduction plan, which was the first install. And now, Gabe, back to you.
Thanks, Kim. The HP Trunk Sewer Rehab project in Boise, Idaho became our first Hobas manhole project. The project began in January of this year with an original scope of 2,500 linear feet of 36-inch flush reline, HOBAS, inside a 42-inch diameter RCP pipe and 3 new manholes. Whitaker Construction was awarded the project and chose HOBAS to supply the manholes. We delivered the project in May, and you can see the picture of the installation in this slide. In summary, our new manhole solution exceeds all load ratings, including ASTO HS20 and HS25. It is a zero leakage watertight solution from the sewer pipe connections to the laminated cone on top, and the highest maintenance-free expected service life in the industry.
Okay, everyone, we want to thank you for at least joining us today on this. I'd like to take a couple of questions. I'm going to be waiting for a few of them to come up on the chat room. We do have a few that have started to come in. And if I could, the first question is, how do I adjust the risers if we need to have the risers lowered in elevation of the casting? Terry, can you address that question for us?
Yes, thank you, John. If it's minor adjustments, of course, that can be made just by taking from or adding adjustment rings at the top just below the ring and cover. If there are major elevation changes, then there's a couple of ways to do it. One is we can provide a section of pipe that's needed for raising the riser, and we would apply FWC couplings, which is what we use to join our pipe with, to make those connections of the cone section that was taken off to the riser. Or we can actually produce at the plant a short section that already has a new cone on it, and we would wrap the FWC coupling to make that joint out in the field.
Okay, thank you, Terry.
Yes.
Another question has arisen. I know some of the FRP thinner walls are used mostly in easements. Can you confirm that our systems are designed for roadway applications?
Oh, yes, they are. I mean, as you saw in the testing in the slides that Kim was talking about, we more than exceed the loading required for that. So yes, we do meet the H20 loading, and the robust system that Hobas has come up with is more than adequate to meet the loading.
Okay. Kim, I think this is a question in your direction. Can you tell me more about the chemical testing and how is this performed on the cone, and what does C581 entail?
Sure. Yeah, that's a good question. I think a lot of our customers are familiar with the corrosion testing that we do at Hobas per D3681, which is string corrosion. But C581 is the standard practice for determining chemical resistance for thermoset parts in general. It's widely used in the industry for laminate parts, and that includes the manhole cones. So in our case, we made a flat sheet that we could then test in various chemicals to determine the property retention. This is a long-term test. It's performed at 30, 90, 180 days in 1 year. And along the course of the test, we weigh the specimens, check the thickness, verify the strength by, I think I had a photo in there of the testing that was done, flexural test per D790. And the test basically predicts the behavior and therefore the expected life in those tested environments.
Okay. Thank you, Kim. Another question has come up with regards to making ties into the risers. How do we tie into a riser pipe? Terry?
Yeah, I mean, those are very easily made out in the field. You can use an inserted T-type connection. When we're producing the manhole, if you know where the elevations and angles of where these lines would be coming in, we could actually provide that when we deliver the manhole out to the job site. But most common would be just putting an inserted T.
Okay, thank you. Okay, this question has to do with backfill. Does the riser require special backfill, flowable fill requirements? Terry?
Depending on the existing soil conditions, it normally will vary, but normally compacted sand or crushed rock are very suitable for most backfills.
Okay. Last question I have, and I'll look back here at the chat room, but um, do we need to pour concrete over the bottom flange for flotation issues?
Well, I mean, our engineers recommend that you put 6 inches over the flange to be placed, over the flange after the riser is installed, if there is a risk of flotation. Actually, that job out in Boise that was on the presentation, they did not do that because they assured me that it would never see a flood condition. So they put just compacted rock, and but that was their decision. So, but it's the decision of the owner, the engineer. But I know we do recommend in most conditions so that it doesn't float is just to put a minimum of 6 inches of concrete over that.
Okay. Another question I'm going to send your way, Terry, is how do you seal the manhole to the top of the concrete foundation or the pipe base T?
Okay, we actually install a FWC coupling on the inside of the riser so that you're getting again that same coupling that we used to join our pipe. Normally, when you say you've got a 48-inch line with a needing a 48 or a 60-inch riser, we would put in the T would actually be a 48 by 48 and then have a 42-inch T-base neck. And we would actually install a 42-inch coupling inside of that riser so that, and that is actually supported by that flotation flange on the bottom. So to just make sure it doesn't move when it's being installed, but it is a gasketed connection and it is leak free there.
Okay. Another question is an interesting one. I don't know who best can answer this. I can fill in a little bit, but maybe Kim or Gabe can address it a little further, because it's kind of a two-part question. Has Hobas inspected pipes or manholes that have been in operation since 1987? Interesting date. I guess, Kim, how far back does Hobas Pipe go? And of course, have we done inspections on our older
Yeah, sure.
installations?
I can take that one. So the first installations of HOBAS pipe in the US were in 1984. The plant wasn't built until 1987. So those plants were imported from Europe. But I can remember one job, one of the first jobs for an industrial application that HOBAS supplied pipe to in West Texas. That was in 1987. And the pipe was shipped from our Houston facility. And about 10 years ago, they needed some replacement pipes because they had some broken pipes in the field that were unrelated to anything Hobas did. They had a gas line failure in the location that caused some problems. And so because of that, we were lucky enough to get some pipes back to the facility. And we actually did not just inspection, but testing of those pipes. And they did terrific, actually better than the performance we had expected. So after that 20 some years of service, they were still well on their way to their expected life.
Okay, and I think we can address the issue of manholes. Obviously, we're introducing the full solution now with these cones, but we have installed for years shafts pipes, correct, Kim, on some of the CSO projects on shafts, and they've been in operation for a number of years,
Yeah, I
just
mean,
as we're addressing the cone.
I think a vertical application is somewhat easier than a horizontal one even. So the vertical shafts, I know installations over 20 years old at hundreds of feet deep.
Okay, I guess it's important to let the audience know that, prior to us developing the cone and going through all of the testing that we have done, a number of shafts and vertical pipes that we have put in the past that had concrete tops and things of that nature have been in service for years. So really the introduction here now is a turnkey total solution from the bottom to the top, all the way up through the cone. So. Question here is, can FRP pipes be used to convey foul air? Does anyone feel like handling that, or I can address the
Yeah,
project we did in New York?
I can take care of it. So yeah, I mean, our pipe has actually been used in some of those applications before. Typically, it's a different type of FRP piping though. One that's a lot thinner and lighter. So it's even though it's fiberglass, it's not exactly the same thing. But yeah, I mean, I do recall a project actually in Oklahoma City where a line was buried that was going to convey foul air. So yes.
Yes, and I follow up with that too. On a job that was done in New York, we actually jacked our pipe underneath the roadway that went from a CO to a CSO to a air filtration system. So the pipe was not really a ductwork any longer. It was a physical structure that needed to handle both, in that case, jacking loads as well as both earth and highway loadings. Another question is, and maybe I'll handle this one too, is this pipe for gravity flow only? Can it be used for force mains or water mains? And the simple answer to that is yes. Hobas pipe is designed for pressure applications up to 200 plus PSI. We have introduced systems of flanges and things to that nature for even manhole access points to these pressure applications. So ultimately, I guess the easy answer is that yes, Hobas pipe, even though the majority of the work we do has been in gravity, is capable of handling pressure applications, both the rehabilitation of pressure work as well as new installations. Okay, how does Hobas manhole differ from polymer concrete products? Do they have a 100-year design life? Well, I guess I'm going to let that go to Terry. I don't think we're going to address the 100-year design life for polymer concrete, but I think we can surely address maybe the differences between the two. I think Gabe made some reference to that in the presentation, and we can obviously address the issue of 100-year design life. Gabe, Terry, how do you want
Yeah,
to handle
I
that?
can address, hopefully part of that again. Their design life, I'm not sure what that is. I know ours is 100 plus years. The main difference is, of course, what Gabe had mentioned in the presentation is, weight. Uh, when we're dealing with large diameter pipe, we can use our T-base and then go up with a 60-inch or a 48-inch riser, and we're not needing a large structure to be able to put pipe in and out. Say if you've got a 60-inch Hobas pipeline coming into a armor rock or a polymer concrete, excuse me, type structure, it's going to be several feet in diameter to be able to accept, the incoming and outgoing line. So that's probably the main difference. I'd say the weight, and then of course the size of the structure you're putting into the ground.
Okay. Gabe, you don't need to add anything to that. You're good. I think we addressed that one.
Yep. I
Okay.
think it was great.
Okay. Another question here, again, doesn't have to do with manholes, but it's a simple question for even me to answer. Do you need thrust restraints on piping, and what type do you recommend? So obviously we're talking again about pipe versus manholes. We have done a number of pressure applications. We do require thrust blocks presently with Hobas CC FRPM pipe, and on manways for access ways to pressure applications, we do require a J-bolting system to anchor the flanges down into that concrete encasement. But all these are doable and are done almost every year with Hobas. Let's see. You cited the cost of polymer manholes as a drawback. How does the cost of Hobas manholes compare? Um, Again, I don't think we want to draw lines. I know we make reference to costs. Each application and each project is different. I think the main thing we're trying to get across is there are manhole systems there that are out there that provide a solution that eliminates the issues of corrosion. Polymer concrete manholes is one that's been very well accepted. There are just some downsides to weight issues that we're trying to address, and the fact that we can, with our T-base, along with our pipe, we don't need to go with larger structures that not even just their polymer concrete manhole, but any concrete manhole would have to do to go around a 72-inch or a 64 larger diameter pipe. Okay, let's see here. We have one more. How do you adjust the rim elevations with FRP risers? We have a project that the grade will increase due to a highway bridge construction in the next 10 years and have to raise a height of 17 feet later on. That's a great question and a great application for us. Do you want to address that, Terry?
Yeah, and that goes what I'd mentioned earlier about, you know, other than minor changes in inches that you can work with the adjustment rings, is that basically we can send or manufacture a riser, uh, and if it needs to be increased that size, we basically provide you with a 17-foot riser with a new cone on it, that's got a wrapped FWC coupling on the outside to make the joint where you would cut the existing manhole. And of course, that cut needs to be made as flat as possible. So, but yeah, that can easily be done by the connections that we can make with our couplings.
Okay. Here's a cost question. How does the cost compare to conventional technology? So I think I'm going to try to address that. I don't exactly know what we consider conventional technologies, but if you're considering just bare concrete structures, all of the ones that we've just been discussing here that are either fiberglass or with polymer concretes are usually more expensive than just a conventional precast. If you start getting into coatings and things to what we would consider conventional, I think you're going to see we become more in line with that. But now we start looking what FRP brings to the table, and that has to do with the issues of lightweight, zero leakage, no coatings, no seams. The advantages that FRP bring to the table over what I would define as conventional manholes, if you want to call it that. Question, do you have any cost comparisons saying for 10-foot deep manholes versus concrete? Terry, I'm going to throw that your way. You've been doing both types of manholes for a long time. Is there any rule of thumb or anything that you would address that question?
Well, again, it depends on the, basically the angle of the pipes coming in and out, what size. Again, we can do it on a T-base that matches the pipe that's coming in and out of the structure with a T-base. If
Okay.
it's a larger diameter, say 10 foot deep, that's going over a 60-inch Hobas, you're going to need a 10-foot diameter concrete structure to do that. So it depends on the instance. When you start comparing a T-base to a cost of a 10-foot diameter riser, yeah, I mean it's competitive, if not actually less.
Okay. All right. This question goes back to pressure. You're not relating to the manholes, but do you need thrust restraints on the pipe, and what type do you recommend? Again, yes, centrifugally cast Hobas pipe for pressure applications does require a restraint or a thrust restraint. Normally, it's a cast in place concrete thrust block. It's what I normally have seen. Kim, or Gabe, are there any others that we've done to address thrust forces other than concrete encasements?
No, no. I mean, to be fair, it's not like all pressure projects are going to necessarily need that. You're going to require thrust restraints. Well, okay. In all pressure applications, there's going to be some sort of thrust restraint, but it always depends on the amount of pressure and the type of soils that are there, right? So if you have a soil that has a high bearing capacity and it's under lower pressure systems, then that might be enough to actually keep everything in place, right? So it's always on a job dependent basis, right? What's important to keep in mind, of course, is that the the joint itself is under strain. So, there has to be an outside solution to keep it from moving.
So John, I
Okay.
can add to that also at these directional changes, it doesn't necessarily have to be a thrust block. There are some longitudinal trench restraint systems made of reinforced concrete that we've pursued in the past. There are different options. So I would say, like Gabriel said, let's talk about these on a specific case by case basis and see what the options are.
Okay. Here's a question. How do you address the differential settlement when Hobas pipe is installed in fill and it connects to a concrete structure? Uh,
I can take that.
Gabe, you want to try to handle that one?
Yeah, so we actually see that pretty often on whenever we're connecting to structures. And the way that we handle that is actually like dependent on the size of the Hobas pipe. If the Hobas pipe has a larger diameter, then it's recommended that we actually like concrete encase, past the pipe to ensure that there's no over deflection at that particular spot. The problem is that if the pipe over deflects, the joint is going to leak because we're still like at a structure. The connection is kind of trying to. There's different shapes involved right there, right? So in smaller diameters, then you actually want to is not that big of a deal, right? Because any deflection is not going to actually be more than what the joint can handle. So it's really again, it's on a job dependent basis on what the solution
Okay.
might be.
Okay. Here's a good question, and I'm glad this question did come up because it's the reason why we make as many fittings that we do. How do we address changes in direction of pipes at the manholes? Gabe or Terry, do you want to field that one about our fittings?
Yeah. So I mean, with T bases, we can actually manufacture any angle that the customer might need. It doesn't have to actually be something standard like 45, 90 degrees, which is what we see in ductile iron pipes and things like that. It can be really anything. And we're going to have the same type of customization with our vertical manholes as well, right? So yeah, I mean, we can make holes, laminate things, and everything like that at any angle that we want. So it is very, very customizable, which is a great advantage of the product.
It's one of the reasons why I believe our fittings are used as much as they are. They improve the hydraulics of a system and how it operates, especially if you're making a 90-degree turn, where most conventional manholes would have a bench head spring line and there would be some disruption in flow in heavy high flow conditions, where with our technology and systems it's minimized and actually improves that whole system the way it operates. Okay, here's another question. Terry, I think you can answer this one. Will Hobas enter into the manhole insert markets as FRP and polymer concrete has done?
Yes, that is a future venture that we'll go to. We're actually looking at increasing, both the size of the risers and, getting into a 42-inch size to go inside of a 48, and then possibly a 54 that would go inside of a 60-inch existing manhole. So yes, that's in the future. We're not there yet, but hopefully we will be soon.
Okay.
John, I think maybe the question was not, to me, that question was meant to say the inserts at the bottom of the manholes where you have plugins from each side and a vertical shaft as opposed to a T-base at the bottom.
Yeah, I took it as an insert, something that I would assume slide into an existing structure. Is that the way we're taking that question?
That's how I answered it.
That's
Was
the
that
way, that's the
in
way I
that
thought.
way?
Yeah,
So we do rehab quite a bit
correct.
already with the product.
Okay.
Yes,
Okay.
what I was trying to say is that, most manholes are 48 or 60 inch, and right now we have 48 and 60 inch risers with cones on them. We could put in a 42 inch or 54 inch, 57 inch inside of a 60, but we do not have the cones for those sizes yet. So that is
I
something
got
we
you.
will get in the future.
I got you. Okay. what do we provide for drop manholes? Terry?
Well, I mean, you can make those connections. If it's going all the way to the bottom, we would manufacture the T base to have that joint in it. If it's just in the riser part of it, then of course you can put we could either do it at the plant if we know the elevations, or like I say, it can be done with inserted T's in the riser.
Okay. Gabe, this is one you and I have been talking about, so I'll address it and then you can chime in. Can NC products be used for manhole risers where round risers will interfere with gas lines or other utilities? So can NC be used for a riser pipe? And of course, our answer is yes, but it does run into the question that Terry just raised with regards to cone types and the auxiliary equipment that would go with it. Do you agree with regards to NC?
Yes, I do.
Okay. So if they were going straight up to the surface and looking at a flat concrete top or something to that nature, then of course, yes, a non-circular structure can be done.
Yes, absolutely.
Okay, this question starts talking about different names, so I'm going to try to break it up. How do you transition from swim drains? Yeah, I'm not going to get into all of that question. I know you guys are seeing the question I'm looking at right now, but can we discuss transition pieces? Again, not a manhole question, but Gabe, do you want to discuss the availability of transition pieces that we can make with fiberglass? Kind of that custom side, if you want to talk about that.
Sorry, John. So we're looking about the 66-inch pipe. Is that
Yeah, I didn't want to get into all of the wording there, but I'm trying to address the issue of transition pieces, which I think is really ultimately what he's trying to get to.
Sure. So no, I mean, yeah, we can definitely transition from pipes with similar sizes, but they don't have exactly same OD. The way that we can do that is with concrete. Sorry, a concrete connection and everything like that with hydrophilic gaskets, and kind of do it that way. We can also manufacture, if they can actually have the same OD as our pipe, we can use our FWC coupling, but that would potentially require some grinding on their end, right?
Yeah. Yeah, so for people in the audience that don't see the full question because it references other products, we have made transition pieces into concrete. We've made transition pieces into steel, actually into steel pressure applications. There's a number of different options that could be done there. Ultimately, we need to match ODs. So fiberglass has the ability to change our OD in a short laminate at the end to connect up to a concrete pipe, for example. Or to a steel, which is usually thinner than us. We have the ability to address IDs and look at how we can address ODs. So yes, transitions into these other shapes and sizes can be done. This question, I guess, is a little tough too. It says, how much lead time is necessary for a customized fitting? And I don't know if that's best addressed by either Kim or Gabe. Terry, but it's really not about manholes. Sounds like it's about fittings. So how would we best want to address lead times?
I think that depends on our current production time, really, what we have to say, depending on our availability of raw materials and current project schedule, because some of these complex fittings can take us days and days to complete. Some can be done in a day. So it's not really the manufacturer, it's how does that fit into production schedule. So I don't think there's someone on this panel that can tell you that today.
Okay. All right, I don't have any. Oh, the one fella did confirm that, yes, he's talking about inserts, I guess within the structure, a manhole structure. So he did confirm that he is looking to slide, I would assume, a riser into an existing vertical shaft. So, which is
if I could
easy.
actually add on that, we've actually done that in Minneapolis. before,
Okay.
where we used like our flush reline pipe to go inside an existing manhole. So they have been used as inserts before. So yeah.
And I guess this last question has to do with Mexico, and yes, you can work with us with regards to projects in Mexico. We have supplied a number of projects in Mexico in the past. So I don't see any additional questions. Um, Panelists, do you have any ending comments that you'd like to make? And I guess we'll sign off and let everybody get back to work. Anything from you, Gabe?
No, I'm good.
Kim, you good?
I would just like to thank everyone for attending today. And if you have any questions, feel free to reach out to any one of the panelists or John Mealy. His information is in the chat there. Thank you for today.
Okay, Terry, anything closing?
Again, thank you for your interest. The one thing that Hobas has the ability to do is manufacture, as you could see in the presentation, that design that we did for that Texas agency. We as long as it can ship, then we should be able to design it. And as far as the risers, we're looking forward to this getting into the market and showing the success that we'll have.
Okay, guys, thank you. Regina, I want to thank you for helping us organize this. For everyone who's attended, thank you for your time. We appreciate you giving us the opportunity to present what Hobas is now bringing into the market for regards to total solution from bottom to top. And if I can be of any service to anyone, feel free to reach out. We do appreciate your time. Thank you and goodbye.
All right. Thank you, everyone. This actually concludes today's e-showcase. Thank you all for attending. The recording will be available at webbuyersguide.web.org. We will send all registrants an email tomorrow with that link. And please visit our event calendar to sign up for future webcasts.
Thank you, everyone. Bye-bye.